So I'm presenting on my project that I deployed and developed this year called Project Iroh, and I'm going to be going over a little bit of the goals and all about the project here. So first, a little classic who am I? Look at this nice, who? We got this nice beautiful picture of me on a boat. I'm the president of RITSec, the Red Team Chief if you have not already heard. I'm big in the Windows if you also haven't heard that already. I really enjoy programming and networking, and as of right now, non-security related things involve maybe my classwork at this point, and that's about it right now. Not anymore, they canceled that. They canceled diving. Yeah, shush. So the agenda today, I'm going to talk about the problem that I found with, for the Red Team that I saw throughout my time on the Red Team. I'm going to talk about then into Windows persistence. I'm going to get into the goals of like what I wanted to accomplish with Project Iroh. Then I'm going to get into some design and features of Iroh, then the direction that I'm currently taking it, and then some future work I'd like to implement to the project before I am finished with it. So the big problem at Red Team I noticed was we had so much Nix tooling. This was more about like my sophomore and junior year. We had so much Nix tooling and so little Windows tooling, and it was all kind of undocumented. The code was documented, but the actual tooling itself was like how to deploy it and use it was not documented. So that really wasn't that useful. Also, another problem we had was it was hard to run a process as another user, and except to make like a scheduled task as that user. And why that's really important in Windows is because you cannot run a process as a user. Therefore, it's not visual to them. The GUI for it does not pop up under their session. You can't modify registry things under the current user. It becomes very painful to do all of this stuff. So that's another problem I noticed. So the solution to this was we need more diverse Windows tooling. So Iroh kind of solves that problem a bit. I would need to document how to use the tool. So when I'm gone, I don't have a bunch of Red Teamers reaching out to me on how to develop and deploy this tool. And then obviously we got to pwn the Blue Teamers with it. So what is Windows persistence? This is a picture of the MITRE attack matrix under the persistence column for Windows. There's a lot of different techniques, and there's even like subcategories in these techniques. There's some that are really good. There are some that are not as strong, but really we want to chain a lot of them together and use a lot at once in order to allow persistence throughout the entire competition or engagement that we have. So this will really get us a nice strong foothold during the engagement. So if they find one or two of our persistent mechanisms, there's more there. And even then, if they find those, is there a way to put it back and detect that? So which ones did I use? I used a combination of a bunch of different persistent techniques throughout the what was developed before. I kind of all implemented what was some of the stuff that was developed before and what I wanted to put now into my tool, all into one project. And I'll get to how I structured it later, but I wanted all of these mechanisms available because these are all really strong. If you have creds on Windows and you have RDP going through the firewall and RDP is enabled, you have access to that box. You're good to go. Or if you have creds and you have any sort of a remote command execution, whether it's psexec or WinRM, this is extremely powerful on Windows, and that's like your main access, and you can always give yourself more access if you have these key components. And then beacons, obviously, is very important. Know if the tool's up. Know if my persistence is still there. Can I run commands with these? And we'll get into the beacons later as well. Let's try to do next on the laptop. Yeah, there's not a lot of memes in this presentation. I apologize. So the goals for the project, like I kind of mentioned before, I want it easy to deploy. When I'm gone, I want people to know how to develop, how to deploy. I want it to be modular. So it's going to be well documented. The code's going to be documented. The namespace and classes that I make are going to be documented how to use them. This will allow for easy modification, easy implementation, and possible changes that need to be made. And the modularity is really the key aspect of this because you can really customize the payloads you have then. So now it's not just one tool that's deployed the entire competition, and once a blue teamer finds it, it's done. It can be customized. It can do different things. You can change strings really easily. You can compile some of it as a DLL, some of it as a service, some of it as an executable. I really wanted to make it diverse in what it could do. And then obviously, I want to be able to run these processes as another user, and that's a really key aspect that I wanted to be able to accomplish. There's a lot of visual, I like to call it memeware that we like to deploy competitions, but on Windows, it's extremely difficult to actually get that visually displayed to the user. So what did I actually develop for the competition is what I want to go into. I developed a service that implemented the following persistent mechanisms. And what this did was allowed us to, I guess running process as another user isn't quite a persistent mechanism, but this is what it was implemented. I was able to RDP into pretty much every box my service was running on at all times. The user Iroh, if you did competition, was on the box pretty much the entire time, unless you stopped the service. And then the firewall rules were always active and were always re-added when you deleted them. Not only that, but I implemented a helper to do some of this functionality for me because I didn't want the service to be doing all of the functionality, because that will give away the service if there's one program doing all of this suspicious activity, implementing all of these known persistent mechanisms. I don't want just the service to be running that, and I'll touch on the helper later. I also made the service hidden, so you couldn't see it visually. You had to find the process that I was running and what it was doing. So it didn't show up in the service list, and I did that with some tokening permissions. All right, so the user. What is the main purpose of having a user, persistent user in the system? This is where we're going to start getting more technical. It allows, for the creds to always be available. You need creds usually on Windows, unless you have like a 0-day, and I'm not trying to use a 0-day or find a 0-day in competition. So what does this give us? It gives me local and domain admin, which allows for pretty much full control over the entire network, which is exactly what we need as a red teamer. And then it also constantly recreated the user. And you might ask, why recreate it if it's already on there? Well, I know you guys, some blue teamers, not that many sometimes, I guess, don't like to, or they've changed the password to my user. And I don't like that because I like to know the password. So what I do is the easiest and most janky way that I figured out is you just delete the user and add it back. And if you do that, it doesn't actually kick you off the machine if the user is still there and you're logged on. So yeah, that works just fine. It is very, very noisy though. You will see this in the logs. The user does show up in the logs. So how exactly was this done then? Well, if anyone's familiar with Windows, you're familiar with the net user command. And the net user command calls upon some Win API functions, which you can just actually call upon yourself using C++. So the pictures shown right now are the two structs that are the main things that I used. So the lmaccess.h is the header file that all these user functions are included under. So that being the net user add, net group add user, and net local group add members. And these correspond to like net user local group add, like local group command, and net user group command, like space command. And this will actually allow me to add the user to groups and create the user. Then, how do I do the domain stuff though? Like, cool, I can add a user and just add them to the local admin, and that's fantastic. But I want a domain admin. So now I have to use the DS role header, which allows me to query domain information from the machine. So now I can get you can use the DS role get primary domain information, and this will actually tell you if it's a domain controller. So if you look at that struct, you can see the machine role, and it'll actually tell you if it's a primary or secondary domain controller, which is pretty cool. And then you can get the domain name from that. So I can create the user with a domain name now with Programmatically. So now if it's on the domain, if I'm on the domain controller running the service, it'll create the domain and enterprise and local admin user. But if I'm on just a client, it's just going to do a local admin. So now I have the Iroh user propagated through the entire network, whether it be local or domain. So I pretty much have hit every point now. So now I have creds everywhere. Oh, I keep wrong computer. All right, so now the firewall. The firewall is very powerful on Windows. So I want to allow myself through. We need to find a way to allow myself through. And I don't, as a red teamer, want to just constantly drop firewall rules. That's kind of like what I would call a dick move, and it's frustrating for a blue teamer, and it's really not fun to deal with. So I just wanted to make sure all the ports were open. And I didn't want repeat firewall rules, because if you know on Windows, you can add repeat firewall rules as much as you'd like, and that's cool. But if we see 500, like, for example, say I named it an Iroh firewall rule. If I see Iroh firewall rule 500 times, that's pretty, I mean, that's probably wrong. Or even if I named it Open RDP 500 times on there, that's pretty suspicious. So I needed them to look realistic. And I also didn't want to have to deal with all the Win API functions you need to set up firewall rules. So I abstracted it all into one function. So it's really easy now to just add a firewall rule by passing it future plan to struct. Right now, it's like 5 or 6 parameters, which is a classic Windows function. So you pass it all of these parameters, and it will do a bunch of checking to see if the rule's already there, and it will add the rule if it's not and enable it. So how did I do all that? Well, I use this lovely iNet firewall rule interface. This interface is complicated and annoying to use and very frustrating, and I spent a long time on it. So this is probably my proudest accomplishment of this entire project, was getting this to work. This interface has a bunch of actions you can use to get the directions, add the rules, set directions. There's a bunch of pound defines. I would highly, highly recommend checking out this example code over here that I put at the bottom, and I'll post these slides. This example code is what got me started in actually understanding it. This isn't really like just one function you can just call and have. You really need to understand that you need to get, I think it's like an H result instance of the firewall rule, like of the actual firewall, and then you need to like query rules and all sorts of other jazz. I'll be publishing my code for it once I publish the project. I'm currently restructuring it so it is nice and pretty and not disgusting, because I coded half of it at like within a 1-week span. But yeah, so I would really recommend checking that out. But this will allow you to insert firewall rules or delete firewall rules that are on the computer and on all the different firewall interfaces. So that's really, really, really powerful as a red teamer to control the firewall. Alrighty, cool. We have all that. Sometimes I like to use a GUI and use RDP, because sometimes, honestly, running CMD commands sucks. So I enable RDP. There's a bunch of really complicated ways you can do it. The ways to do it through the GUI are like the new Windows GUI enable remote desktop thing. And then there's the control panel, obviously, that they're trying to get rid of. Love the control panel. But then you can use CMD and PowerShell to enable a registry key. So I just decided to do that programmatically, because that's easy enough. Modifying the registry is easy enough. This is the only actual code you'll probably see in this presentation. So what did I do? The process, very simple. WinReg is included with Windows.h. A lot of things are included with Windows.h and rely on Windows.h. So I'd usually recommend, if you're getting a lot of linker errors, to just try including Windows.h first, not below it, but above it, because then it'll link everything properly and it will stop complaining. But you'll see errors like missing D word, and then it won't know what a D word is, and that's a Windows.h thing. So I open the registry key, fantastic. I then decide to check the value, which is a little more irritating than I figured it would have been. But if the value is set to 1, I know 1 is false on RDP. That means do not enable RDP. I guess it will deny the connections. And then if it is that, I want to change it to 0, obviously, because I would like the connections in. So yeah, we change it to 0. And this is not reliant for the entire time of the competition, but it is pretty solid, especially if no one checks RDP settings. Cool. So that's like the meat of like just misconfiguration persistence that I've included. Now we get into beaconing. So I've talked about beaconing a ton here at RITSec, but just a little generic overview again. The service will send a heartbeat to the C2 that I have, and it will check in and say like, hey, I'm still active, like still alive. And then it will allow itself to receive commands and allow those to be run on the system, usually as system, because the service runs as system. And then it can be, my plan is to implement many different transports, so it's not just for, say, a web beacon or a TCP beacon or a UDP. I want it to be able to be very versatile and modular and be able to call upon whatever transport it wants. Doing this, the actual beaconing function should be almost the same. The actual transport functions that are being called should be different, though. So hopefully, if implemented properly later on, I can be very, very modular about it and allow any future people who want to use the tool to pick what they want. So what exactly did I use in competition, though? Because I kind of just gave away that I didn't really implement something because it was a pain in the ass. So I used Scuzzy's anomaly bot that he had made a couple of years ago, and Kyle Corretto's archived an old Arsenal C2 server and team server that the anomaly bot worked with. It was very interesting setting them up. I learned quite a bit about things that I didn't know about before with Docker and everything, and how to include different libraries. Shout out to Adler for helping me set all that stuff up. Really appreciate that. But the reason I didn't implement my own is because setting up a proper C2 and a proper reliable C2 that was going to work through the entire competition wasn't the main focus that I wanted to hit. I wanted to focus on hitting some of these other things. So it's okay sometimes, in my opinion, to use someone else's already working, tested stuff. I do plan on implementing my own in the near future, but as a temporary, like the competition is like in a week or two, I need something though that works now. I use this, and it was very reliable. Alrighty, the big other thing that I was really happy about with this project is running programs as another user. People who've done Red Team on Windows can attest before, it is a pain in the ass to run anything as another user, and it causes some problems with running certain malware. So I want to allow Red Team to impersonate a user. So how do we go about doing that on Windows without using passwords? Because we don't know. Say we even do know their passwords, and I have to store that somewhere. I don't want to use their passwords. There's another way. Windows uses tokens, so I can impersonate a token. So how do we go about impersonating a token? Well, first, there's a whole Win API that allows you to get tokens and set tokens and use tokens. So what do I do first? Well, I want to know, first of all, whose token am I even impersonating? So I have to get all the logged on user sessions. For example, in competition, it's usually one, unless there's a bunch of people RDP'd into a domain controller. But so it's usually one. I'm making an assumption with that for competitions. In future revisions, it will just run as all of them. In my opinion, I don't know if I want to implement like more checking, but for now it's one. So now I have their SID. I have their session ID, which I can pull their user information from, and that has their SID. If we jumped back to the other slide about users, their users have SIDs. So now with their SID, what I can do is I can get their token with that SID. There's like an obtain token with SID function in Windows. You need to be system to get this though. If you are not system, it will not permit you to do this. That is the big thing. So once I get the SID though, I pull the token and then I use the create process as user A function. And the first parameter is just the token. So now whatever process, it's just like create process, but I pass it the token as the first parameter instead of whatever. It just adds a parameter on, and now I can run processes as another user, which is really cool. But then I have one more issue now. How do I tell it what program to run? Dynamically. I don't want it to just be, okay, you're only running this program. I want to run all my fellow Red Teamers' malware. So I was like, oh, I could write a file, but that's kind of janky. I was like, why not just use the registry? That's what it's used for anyway. It's used to hold settings. So the program would check the registry key that I designed for a program string to run every X amount of time. And once it was X amount of time, if it was the default thing that I set it to, I think it was like system. If it said system, it'd be like, all right, I'm not running anything. But if it wasn't, it would try to run whatever path you passed it. So for example, I did calc.exe or paint.exe or mspaint.exe, and it would just launch as that user. So boom, success. And it worked. It worked very well for running a lot of things, except Enzo's ransomware for some reason didn't like it. So didn't have time to debug that mid-competition. So I'm gonna take a break because I probably am talking really, really, really fast. How am I on time? About 25 minutes. Anyone have any questions? Real quick, I got like 3 more slides. I'm looking at the Twitch chat. Thank you, Philip. Alrighty, I'm gonna move on. If anyone does have questions, workplace, or I'm still not done, so give me a sec. So a couple things I wanted to implement. So cool, I have all these features. I don't want the service to run all of them. This would be very bad. People who are in competition, a lot of them found some of the very lazy beaconing that I did, and they doxed Red Team, which good on you, but stupid on me. Good. Apologies. So yeah, these actions that were easily caught, I did tend to run from a helper that I compiled that did some of these interactions. So for example, beaconing back, I called upon an exe from the service to do that. So the network traffic was coming from the exe, but then you have to find what's running the exe. So that is now a problem that you have to find. Instead of just going, all right, here's the service, it's running as this. Bradley's shaking his head because he's upset about it because he couldn't delete the file. So now this binary is way more diverse because I can run this same binary or the same executable like 5 times, and it does a different thing every time based on the parameters I pass it. So that allows for the service to just call a bunch of these binaries spoof them as something else, and then call it a day. So now it's more hidden. So now I'm going to talk quick about the direction that I'm taking the project and then the future work. So currently this is what I'm implementing to publish. This is already kind of outdated UML, but it's a very nice sketch that I've been trying to follow. I'm restructuring all the project into a static library with a namespace. And that namespace will contain classes which you call upon in order to implement the persistent mechanisms you want. So once it's compiled in a static library, you're going to be able to compile it easily and use the functions in a DLL, an executable, or a service. The only difference between all of those is the entry points. And writing those entry points is super easy, especially if you already have all the functionality in a class. So the big benefit to this is if you kind of take a look, I know it's probably minuscule on the screen, especially on stream, but all the private functions are all the things handling it. And then the public functions allow you to set what the rule, like for example, let's do the user. I can set the username and password. I can set how long it's going to wait between sleeps, like how long it's going to check for the user. And then I'm going to start the user check. And that start user check is going to call the user main thread, and it's going to thread the program. And it's just going to constantly then check for a user. And that's its job. That's what the job is. And until otherwise broken. But right now, it just runs until it runs. I might implement a kill switch. Might be a good idea. Nope, wrong laptop. So I guess, lastly, future work for the project. I want multiple transport beacons. I want to implement my own beacons. This is something I've always really wanted to actually take the time, flush out, and do. I've made some really trash ones and janky ones. They kind of work, but I really want to take the time to implement proper beaconing with the C2 that I designed because I want that experience of setting it up as well. I want to document the C2 that I made because I don't want to make it complicated because we've got some complicated ones already. I don't want to do that. I want very simple. I'm going to document the API that you have to pass to it. It's going to be very simple for new red teamers to just be like, I just need a shitty C2. There it is. It works. Great. That's what I'm looking for. That's what I'm trying to design. And then I need more ways to hide the agent. This is great in competition. In the real world, I want more ways to hide this thing. This is very not that well hidden. But as of right now, it does what it needs to do. But in the real world, I think it would. It's very noisy, and it needs to be toned down for real world use. So I guess that's the presentation. Does anyone have any questions about the C code, the project itself, were they blue teaming and they'll want to understand how something works? If you can ask me later, but now I'm on stream, I can broadcast to everyone. It's going to be in a recording. I'll give the Twitch chat a second. All right, yeah, we're looking like that. We're done here. Yeah, Enzo got a question. So Enzo for the chat. The question for the chat, Enzo was asking, how did I actually steal the token? So, I mean, I guess steal's a strong word because it's actually a properly implemented function that has legit use that I just misused. The service is run as NT Authority system, so you already have the permission. When I was testing it, I did use psexec system shell because that's the only other way I know to get a system shell. But also, you can. When I was running the helper was also running a system because the service was calling it. So either way, as long as I'm running a system, I can pull that access token from the user, or I can pull the actual token the user has, and then I have full reign with it. For competition, I was using the helper because I was not sure how noisy it was, and I was just calling the helper, which then looked at the registry key, and then took the string and ran it. Service Dell Iroh, obviously. Yeah. How do you stop it? So that's a good question, actually. How do you stop it? So you need to find the service binary and stop it. So there's a couple different ways to do that. You're not actually able to see it through services.msc like I previously mentioned because I changed the permissions for it. But I did not change the permissions on the binary. I only changed the permissions in the services. So you couldn't see it in services, but you could see the actual process running on the machine clear as day. But the question is, what process is that now? A good way to track it down is, now I told you what it's doing. Look for those functions with a monitoring software. There's ways to look for functions that are running on the system. Also, the logs. The logs might tell you what it's doing. I'm not 100% sure. The logs might say which executable. Another sneaky one. Oh, I time stomped it, so that's kind of mean too. But you can look at strings. I didn't encrypt any of the strings. If you looked at the strings of the program, you would see Iroh. Like, you would see Iroh and like the password clear as day in the actual like binary. If you did like process explorer and clicked on the process running, there's only so many processes running a system. And I know during competition, you probably are stressed and don't have a ton of time to look for it. But there's a lot of different little like tells that you can find it that it's there. I'm sure Philip or some other blue teamer would actually have a better idea and process of finding it. I just know what it looks like. And the binary, once you find the binary, you can't just delete it. You have to end the process through Task Manager or something. And once you end the process, then you can delete the binary, and then you're good.
Say you have a way to find it from Task Manager.
Let me know how that. Enzo says, do you have a way to hide it from Task Manager? Let me know. Let me know if you do that. Yeah, let me know if you can hide from Task Manager. Enzo's giving away some spice right now. Oh, Enzo's making my program invincible. That's kind of mean. That's kind of mean. He's hiding from Task Manager. I want to deploy it on my own box and experiment. Absolutely, man. You can deploy it on your own box once it's public. I will help you set it up. I don't have an issue with that. I'm not seeing any other question. If your question's higher up, oh, hold on. If for future work for a team is needed. Yes, Shannon, that is the goal, is make a shitty C2. Alrighty. Well, I'm done. I've taken enough time. It's time for Q to present. Q's got an interesting presentation. He did a phenomenal project last year, which saved us during the CT.